Hello guys, so this is going to be the first video of the series, and this will understand Solidity language and we'll understand the high level concepts in it. So learning Solidity is just similar to learning any other language. You could get started in many different ways, and the way I prefer is I would first want to read like a bare minimal tutorial and then like maybe watch a couple of videos like the small ones, right, which give me an overview, and then write some code, and then after that I would want to read the docs, and later like at the last stage I would definitely want to read a book also because it covers everything in detail. So if you look for Solidity tutorial, you'll find many good sites on which like you can read docs for Solidity. So the first, like one of the first sites could be Tutorials Point. Another very good one is the Solidity docs, which is soliditylang.org. For sure, like do go through like the official docs because these are very descriptive and really nicely documented. But like as a starting point to cover the bare minimum, you can start with the tutorials point, and this is what we'll look at today. Along with this, you could also search for few examples of smart contracts. So you could say Solidity examples, and then here you'll say Solidity by example. So here you see like a few sort of hello world and advanced smart contracts which you can have a look and try to understand. So Solidity is a contract oriented high level programming language, right, which is used for implementing smart contracts. So Solidity is similar to C++, Python and JavaScript, and it runs like the code runs on Ethereum virtual machine. Solidity is statically typed, means you could declare complex user defined types or the other types also which comes with Solidity. Your code needs to declare like the variables as one of those types, and after you've written your code you could compile it to make sure like your code conforms to those types or not. So it supports inheritance and libraries, right, and as we saw, you could declare complex user defined types which is known as structs. So you can use Solidity to write contracts, and using Solidity, since it is oriented to smart contracts, writing a lot of these smart contracts is very easy in that language. So what is Ethereum? Ethereum is a decentralized blockchain platform that runs smart contracts, right? And all of these smart contracts, they run in the Ethereum virtual machine, which is EVM. So Ethereum virtual machine is a runtime environment for smart contracts in Ethereum. The Ethereum virtual machine, it focuses on providing security and executing untrusted code by computers all over the world. Basically, your smart contracts are untrusted, right? Nobody trusts them. But EVM, like you could run those in EVM. And EVM makes sure that any of that code does not cause denial of service attacks, right? It ensures that the programs do not have access to each other's state. Like your code or some other code like which is having like billions of dollars, they would all be executing in the same EVM, but you would not be able to access their state or like to modify their state, right? So all of these states are kept separate from one another. So let's have a look at the first smart contract, which is, and again like I'm referring to Solidity by example. So do go to this link, right, or you could have a look at any other simple smart contracts to understand what is going on. So here, if you see, the contract syntax is very similar to the way we declare class in like languages like Java or JavaScript or like C++ and all, right? So we have a contract and we declare the name of the contract. Here it is hello world, and in that we are declaring a variable. The variable's name is greet, the value is hello world, which is a string, and this is the type. That's why Solidity is statically typed language, because you're declaring the type also, and you give the modifier. That means the variable greet could be accessed anywhere from outside, and that's why it has a public modifier. And the first line, it always is a pragma line, right? So you say the pragma Solidity. So this basically declares with what version of Solidity should this code compile. So let's have a look at a second contract, a very simple one. Again, the first line is pragma Solidity, which tells that against what version the code should compile. Next is the contract. So contract modifier is similar to the class which we declare in other languages, and the name is counter here. And then we declare a variable. The type of the variable is unsigned integer and the modifier is public. One of the things that is different in Solidity is that the variables are always initialized with the default value, which is not the case in other languages like JavaScript, where the default value is undefined for most of the variables. And next we declare a function. The function's name is get. The modifier, like the visibility, is public and it is of a type view. View means it is just returning the stuff, right? It is not modifying any of the existing state. And then it says that this returns a unsigned integer, right? So it's returning the count, and the count is of a type unsigned integer, so it is returning it, and we return using the return statement here. And next we have a function whose name is increment, and this does not return anything. That's why we don't have any return statement, right? So it is just public, and also the view is missing. The reason view is missing because we are modifying the state here, we're incrementing the count. Return is missing because we are not returning anything, so the return is void. Next is we are decrementing. Again, there is no view and there is no return statement. We are modifying the state and we're decrementing the count by 1. So from this smart contract, you can see that understanding or writing programs in Solidity is not much different if you know some other programming language. So let's come back to the tutorial and try to understand some of the basic things that we'll need in order to write smart contracts. So I'll not go into the advanced stuff, right? I'll just go some of the basic things that will allow us to start writing the contracts. So first is the types, like these are different type of variables we can declare in Solidity. So we have a type of a boolean integer which could be declared as int or uint. By default, whenever we're declaring int, it is declared with the size of 256 bits, but you could declare integer of lesser bits also, with like a bit size of 8, and you can keep incrementing the bit size by 8. So the next would be 16, 24, 32 and all, and you could go to the bit size of 256. And if you're just declaring int, by default the size would be 256. Same for unsigned int also. By the way, if you're liking the video so far, please subscribe to my channel and hit the like button because it motivates me a lot. So next we come to floats or like fixed point numbers. So we could use, just like for integers, we could use int or uint, and the default size is int 256. Similarly, for floating points or like fixed point numbers, we could use fixed or unfixed, and by default the sizes of that is fixed 128 x 18, means 128 bits are used for storing the number and 18 bits are used to store the decimal points. And you could also declare it of a specific size. You could say that m bits would be used for storing the number and n bits represents the decimal points. And m should be divisible by 8, and it goes from 8 to 56. Similarly, n can be from 0 to 80. And the next basic type is address. So address holds a 20 byte value representing the size of an Ethereum address, right? So all the public addresses, they could be assigned a variable of a type address. So let's have a look at the next is variables. So variable is very similar to the variables we declare in other languages, but the thing to note here is, so the variables could be state variables which are stored on the EVM, and next is local variables which are local to the function, and those are cleaned up after the function execution is done. And then it is the global variable which has some of the default values which are stored about the blockchain, information about the blockchain. Then we have variable scopes. So the scope could be public, internal or private. So public is that it's available to everyone. Internal means it is available to the contract or any contract that is deriving from it, right, using this keyword. And private means the private state variables can only be accessed internally from the current contract, right? They are not defined in the derived contracts. And operators are very similar to operators that we have in other languages, right, like plus, subtraction, multiplication and all. or modulus, increment, decrement and all. And like to verify like whether two values are equal, we could use equal, double equal sign, and not equal, greater, less and all. So I'll just skip that, right? Like the operators are pretty much same as other languages. And then we have loops, which is again somewhat similar. We could use a while loop, do while loop, or a for loop, right? So we can skip that. And next is decision making, which is similar to if else statements. So if, then we have if else, and then we can use if else if statements also, which is also similar to the other languages. After decision making, we have strings, and strings are similar like we have in other languages, and the string could be also replaced with byte 32, so they could be sometimes used interchangeably. So the escape characters are similar to other languages. Again, I'm quickly going through it. And after strings we have arrays. Arrays are a bit different here because in some languages arrays are of fixed size, but here arrays could be of a fixed size also. Like if we just add a size, in that case it is declared as fixed size. But if we don't pass the size, like if we declare like the type of the array with square brackets and then we declare the name, in that case a dynamic array is created, right? So you could keep pushing to this array and the array size would keep incrementing. And again, you could use length and all just like you use in other languages. And in the dynamic array, if you use push, you can keep adding elements to the end of the array. And after array we have enums. Very similar, but like if we are returning a enum from a function, right? Like here we are returning an enum, and the value which we get is the index of the enum, right? So sorry, here it's large, so 0, 1, 2, and here we get the value as 2, which is the index. And then we have structs. So this is very important. Like any specific sense, Solidity is a typed language. You could declare these structs which encapsulate the other stuff, like other variables that are within. Like you could declare a book, and which has a title, author, and book ID and all. Mapping is similar to a map, which we have in other languages, right? In JavaScript, like which you have an object, but in Java we have a map, or like some other languages. So you declare, like in the mapping, you declare the map as a mapping, and then you declare what's the key and what is the value it points to. So here you declare the mapping with the key as address, and it points to an integer, right? So basically you're declaring the balances. So this balances array would keep, like on the left side, keys as the addresses and the values as balances of each of these addresses. So when you update a balance, like all you're doing is like you say balance and you pull the sender, right, from the function, like from the function call. Like every function call has this message.sender. So using the balances and then using the square brackets, you access the value and then you set the value. In case the element is not there, in some of the languages you might get any error and all, but in Solidity, just like any other variables, the mappings also points, like the values are the default values if the actual value does not exist. So I'll skip rest of the stuff. Now let's go to the functions. So we saw like functions also in some of the contracts. Again, let's quickly have a look at the contract. Like functions where you declare function name and then the modifier, like which is the visibility modifier. Like view tells whether it's just a read-only type of a thing or whether it modifies the state, right? In view you don't modify the state, but in other cases, like if it's not a view, you could modify the state. And if you declare this function as a view, when you compile, this will throw a warning that you're modifying the state within a view function. And then you say returns, and then you declare the return type. So return type could be a single value or it could be a tuple also. So let's go back to the tutorial, right? Again, like function name, parameter list, scope is the visibility, right? And then you declare like returns and all. So here like public view, and you say what it returns. So to call a function, you use dot operator. just like you use it in many other languages. And when you're calling within the same contract, you don't need to use dot operator. Like, but if you're calling on different contracts, just like if you're calling functions on different classes and all, you would use a dot operator. But like if you're calling the same, there's no need to use this and all. Like in some languages you might use this, but here you could just call the function with the same name, and you could say integer to string, and this function is called, and you're passing the parameter, which is the result, which was integer value. Again, Solidity is typed, so you can't pass a string here. If you try to pass a string, the code won't compile, and like you'll get a compilation error. So we saw a type of a view, right? Basically, view is not modifying the state but reads the state. Something which is a pure, it doesn't even read the state also, right? It's just a pure function. You pass some inputs, it works on those inputs, and returns the result after working on that.
By the way, if you're liking the video so far, please subscribe to my channel and hit the like button because it motivates me a lot.
So we do have inheritance in Solidity, which allows us to reuse the code. So like here you could declare a contract C, and then you're declaring a contract, a derived contract, like which is a child of a C. So you say that contract E is of a type C. Couple of other important concepts are interfaces. So just like in Java or like C++, you could declare interface in Solidity. So you say that interface, it's a calculator, and you just declare the function, you don't implement it, and the contract which implements this interface, and you just use is the same you use for inheritance, and then you just implement that function, which is get result. So this is how ERC20 tokens, like they also implement a common interface, which is ERC20. And then we could have reusable code as part of library. So you could just declare a library of search, and you could just declare common functionality. So this is similar to, rather than having is a relation, because a lot of times is a might not be useful. So we should just go for has a, means like we should just declare reusable components or reusable utilities which are pure, which consist of pure functions, and then call them from other contracts. Another very important thing is that in Solidity you could declare events, right? So here, like whenever somebody deposits some money, you could declare an event and then emit a deposit event, and then other clients and all, they could listen on to that event, right? Like here in this JavaScript code, right, you say that whenever there is a deposit, you just call this function, right? So you get all of those events here in JavaScript. So other clients, they could listen on to the events that are being emitted from the contract. Let's try to see another example of a contract. So we'll look at ERC20 token. So basically ERC20 token is an interface. Like this declares that what a contract should implement in order to qualify a ERC20 token. So here it should, these are all methods that like the contract should have. So like transfer from is one method where you say that who's the sender, who's the recipient, and how much amount you want to transfer. So a default implementation of ERC20 token comes with Open Zeppelin. This is an open source project which you can find on GitHub, and here it's Open Zeppelin. So it has like a lot of different contracts where you could go through. So like again, you go to contracts and you could see all the different type of contracts you can implement. So like in finance, right, you could just say payment splitter and have a look at these contracts. So these are a bit advanced for today's tutorial, but have a look. Mostly you'll understand all of these contracts based on the concepts that we talked about and learned. So let's continue with the same example. So you could declare your own token, which basically extends from ERC20 token. So ERC20 is the Open Zeppelin contract. So you're basically declaring the URL from where you want to get that ERC20 token, and then you declare what should be the name of the token and what should be the symbol, right? And basically you say that you want to add these many tokens for the sender, and then so this is another contract which swaps the tokens. So basically you want to swap the tokens by using the transfer from method of the ERC20 token, And here if we say we have a contract which is token swap, so basically what we want to do is Alex has 100 tokens from Alice coin, right, which are ERC20 tokens. Bob has 100 tokens from Bob coin. Alice and Bob, they want to trade 10 Alice coin for 20 Bob coin, right? So Alice or Bob, they deploy this contract. So when they deploy it, they would initialize and they'll call the constructor with the various values and all. So after Alice or Bob, they call the constructor and add all of these values. So one of them will call the swap, and when they call the swap, this safe transfer from is called within, right? So this is some validations which are done. So you could do the validations using require. So if these are not met, like these validations are not met, the transaction is going to be rolled back. So you call that the transfer from you, and basically the safe transfer from is a function in the same contract which calls a transfer from on the token, right, on the ERC20 token, and it says that who's the sender, right, and who's the recipient, how much amount. So basically whenever this is called, so they'll see a transaction on their own wallet which they can approve, and once they approve, the transfer would be made. And then similarly, like the Bob code, Alice and Bob, they'll get those transactions, and when they approve, the transfer would happen. So this is how easy it is to create a new contract. So this video was all talk, but in the next video, it would be all coding. That means we'll create and deploy our first contract on the Ethereum blockchain. If you like this video, please give me a thumbs up and subscribe to my channel because it motivates me a lot to make more such videos. I know this video was all talks, but the next video is going to be all code.